Hello everyone, my name is Robert Lipovsky and I work as a malware researcher in ESET's virus lab in Bratislava. Today we'll be speaking about banking Trojans. Now as we all know, malware today is about stealing money. That's a well-known fact. And there are actually different ways how the attackers can steal the money from the victims, from less obvious ways, such as various shady advertising campaigns, collecting the users' browsing habits, delivering targeted apps, and making money like this indirectly, or the range varies. And the example of banking Trojans, it's a much more straightforward approach where they would directly rob the user and target his online banking system or payment system, whatever. So this is today's agenda. These are the malware families that I'll be mainly focusing on. And I'll be showing technical analysis of some of the features, some of the more interesting features that I would like to point out that caught our interest. Hopefully not too boring. Then I'll add some statistical data about the prevalence and about the distribution of the malware. And during the course of the presentation, I think it'll become obvious why it's important to deal with this stuff and why these malware families are significant. So without further ado, let's get to it. And as an introduction, I think I put this slide about Zeus and SpyEye. Now, I won't be focusing on these because there's been so much said about these, and they've been around for quite some time. So only for the sake of completeness, some well-known facts. These two malware families were rivals at first. Then the Zeus source code were sold probably. The authors stopped development, and there's been something like a merger between these two families. And these banking Trojans, they use the common techniques of manning the browser attacks. Then when banks added second factor authentication, like MTANs, SMS messages, they reacted with using man in the mobile techniques, where mobile malware would be forwarding the security messages to the attackers, and variants of these were targeting Symbian, BlackBerry, and Android platform as well. So this is a screenshot from an old SpyEye bot builder. Over here, you can even see the option to uninstall Zeus on an infected machine. And even though Zeus and SpyEye aren't that hot anymore, they're certainly still active. They're still active. They're prevalent. This is a screenshot from not such a long time ago, and it reads. We found this in a packer, in a custom packer for Zeus. And it says, hey, not 32 guys, your last work was very good. I was really surprised. I spent over 4 hours trying to fix these detections, but their better man still stands. Come along, little doggy, come along. Muhahaha. I mean, come on, the better man still stands. Okay, whatever. It was quite funny finding this message in the malware. But as I was saying, this malware is still out there. It's still robbing users. And before I continue, I added some statistics of the distribution of Zeus and SpyEye. Now the big purple sector, that's rest of the world, and these ones are Turkey, Spain, Italy, Argentina. For SpyEye, it's quite similar to Zeus, and as you can see, the distribution is pretty global. It's pretty spread all over the world, which will not be the case in the examples that I'll be focusing on later, as those will be targeting mostly Russian-speaking countries and also originating from Russian-speaking countries. So let's talk about RDP-Door. RDP-Door, an interesting piece of malware. First samples were detected in 2010, and the way it works is that it uses remote desktop to enable the attacker to log into the victim's machine. And the attack is pretty manual, so this backdoor will enable the attacker to connect to the victim, and then he will literally have to watch over his shoulder and wait for him to connect and to enter some credentials and then misuse those. For that, this malware uses components of legitimate software called ThinSoft Btwin. And it also uses some pretty neat, interesting techniques for bypassing some security mechanisms. It has some techniques for avoiding AV detection. And for the cost of $2,000, you would basically be getting a bot builder and access to an administrative panel. And basically, that's the price. You can pretty much buy this malware on underground black forums. And that's the way that modern malware works today. The criminals using it for stealing aren't necessarily the same ones behind programming, and it's the whole scheme of organized crime. Now, statistics, as I was mentioning, the big blue part is Russia, followed by Ukraine and Kazakhstan, and this graph will be similar with all the other examples. And the reason why these bad guys are targeting these countries with this malware is that they actually have quite similar banking systems, so they're able to target all of these regions at the same time with the same software. Okay, let's take a little look under the hood how this works. The installation of RDP-Door is pretty simple. When the dropper is run on the affected computer, it will send some system information to the command and control center, and then the command and control server will authenticate the infection and provide the Btwin software for installation. So this is what it looks like. That's the URL up there. There's some bot ID that's being sent, information about the system, Windows version and service pack, whether it's a standard user account or an administrator account. Then the response, there's a standardized protocol which RDP-Door is using, starting with this web tag, and then there is an R command, which is basically sending the components of the Btwin software to the infected computer. And then the client will respond with status information, whether the installation was successful or not. And right there it says that everything went okay. Okay, I have a little demo showing you how the attackers actually steal the login information for the computer. And this is how it works. It's installing an extension of Gina, graphical authentication. So we infected the machine on a virtual replicator. That's the sample that was run, rdpdoor.aa. Now we're checking in Regedit whether the appropriate registry entry was made for the Gina extension. And there it is. Gina DLL is showing to xtgina.dll, which is the extension dropped by the malware. And once that's installed, we'll restart the system. We'll fire up Wireshark on the host so we can see what it's sending out, what it's communicating. Enter the password. Username is administrator, password is password. Switch back to Wireshark and wait for it. Moment of surprise. And there it is, username, administrator, and the password, followed by the computer name and the fact that it's an administrator account. So using this simple yet effective technique, the attackers are able to get the login credentials of the victim, and then using the Btwin components, they will remotely connect to the computer. And the advantage of using this between software is that the user will not actually be logged out of his session. So they will literally be watching over his shoulder and waiting for him to access his bank. These are some of the commands from the protocol that RDP-Door is using. The more interesting ones, remember, that was from the installation used over there. Then T is for between back connection initialization. With that functionality enables RDP-Door to deal with NAT. And then the U command is used for updating the modules of the malware. So with the U command, a new dropper with a new configuration embedded inside will be provided. Fairly simple malware, but quite effective actually. Shelldoor is something similar. The price on the black market is also quite similar. It is the MO of Shelldoor and RDP-Door is pretty much the same. The attacker will be trying to connect to the victim with remote access, but it doesn't use between software. This time it uses TeamViewer, which is again a legitimate application, and the advantage of using a legitimate application that is signed, one advantage is that it is able to avoid suspicion. It is signed components, so it at first glance appears pretty legitimate. And the second advantage is that using TeamViewer adds another level of anonymity since it's a cloud-based service. Statistics, again, quite similar to before. Russia, Ukraine, Kazakhstan. And this illustration actually shows how the TeamViewer connections work. So first, the infected host, the infected bot, would contact the TeamViewer cloud, request the cloud ID. The cloud would reply. Then this ID will be set on the client. And then, due to the infected binary will, the malicious binary will connect to the Shelldoor CNC and send the TeamViewer credentials to the attacker. And once he has that, there's nothing standing in his way to connect to the computer via the TeamViewer infrastructure. Taking a little look under the hood, these are the components, the legitimate ones. That's the TeamViewer XZ and TeamViewer DLL. What the malware puts in place is it's a TV DLL, which acts as a proxy DLL. Basically, it does some simple DLL hooking. And this is what it looks like inside the DLL. These are the functions of the DLL that are being hooked. This is where the original TSDLL is loaded. The function hooks are installed. Down here, you can even see the command and control URL. These are the bot commands that Shelldoor is using. There's the ability to download and execute additional modules, thus greatly expanding the functionality, the capabilities of the malware. There's a kill feature to delete all the files, to hide its tracks, and stuff like that. And as I said, well, this malware is not only for technically skilled people. Anyone, any criminal basically is able to buy this and do crime using these tools. So this is a screenshot from more of a user perspective of this malware. This was taken after a takedown of one of the CNCs. And what you can see here are the different banks which the malware is targeting. These are Russian banks, iBank, BSS, PSB, Sber, etc., etc. Okay, and Carburp. Carburp, unlike the previous two examples, is slightly more sophisticated, and the price tag also confirms that. It's more expensive. And so for this price, what will the client, the criminal, be getting? He's again getting an access to a bot builder, to an administrative panel, and this malware, unlike the previous two examples, works differently. This is a much more sophisticated and advanced malware. It's modularized. There are plugins for it, plugins which are targeted directly at specific banks. And depending on the modules, the plugins that you're buying, the price will depend on that. And also the amount and the level of support. That's right. These people are also providing support for this malware, technical support, and also stuff like they will provide you a new variant once this bot is being detected by AV engines and stuff like that. So, and another important fact about Carburp is that it's also sold on underground forums, but it's not sold to everyone, so it's a more closed circle. As I was said, it's customizable to target specific banks, and the way it works, similarly like Zeus and SpyEye, is that it's using man-in-the-browser techniques. It installs the DLLs, injects DLLs into Internet Explorer and Firefox, and it is really a Grand Theft Trojan. There are real-world incidents where the usage of Carburp was proven, and these are cases where millions of dollars were stolen. So statistics, there are two pie charts this time. The last time I did a presentation on Carburp, this is the chart I used, and again, Russia is in the first place, followed by Ukraine. But the point I was making is that this time, Carburp attackers are expanding and attacking more globally. Ukraine is followed by Spain and then United States. So it's not only focusing on the Russian-speaking region. And then when I updated this graph for this presentation from April 2011 to present, it's still the same graph as we've seen before. Russia, Ukraine, Kazakhstan, they're in fourth place. So previously I was saying that, okay, they're globalizing, they're broadening their horizon. Now what, they're going back? Well, the reason for this isn't actually that they're pulling away from the global markets, but they're actually, the reason for that is not that there's less detections in the USA of Carburp, but there's much, much more detections in Russia, for example. These are the time statistics for Russia. As you can see, at this period of time, May and June of this year, it has increased rapidly. And the reasons for this is that several cybercriminal groups are behind Carburp. So basically, more people have been working on this, more people have been using it. There were changes in the people behind that, and these changes are quite visible during our analysis of the code as well. And on the bright side, though, there have been also a few successful takedowns of command and control servers of Carburp, which were coordinated by Group IB, which is the main company doing the investigations of cybercrime in Russia, assisted by the Russian police. And the most visible impact that it had on the detections is between November and December, where there was quite a dramatical decline thanks to the takedown of a couple of CNC servers. Okay, these are the bot commands that Carburp is using. To point out some of the more interesting ones, there's the kill user option, which is there to better cover their tracks for the attackers, where the whole Windows user account would be deleted, and thus making forensic analysis a bit harder. And Carburp, as I said, it is much more sophisticated than the previous two examples. It has some pretty nice self-protection mechanisms. It has techniques for bypassing AV emulators, such as doing many calls of GUI APIs. And the code injection method has changed between these two versions of Carburp. Before it was using ZW resume thread. The later version was using ZW APC thread. The later version also was using an encryption algorithm for encrypting its commands and the strings inside the binary. It would do a better job of authenticating on the CNC, so it would be much harder to infiltrate the botnet and carry out an investigation. And a couple of other tricks employed as well. Some basic rootkit techniques for hiding in the system, detecting the hooks installed by AV engines and uninstalling them, unhooking, and stuff like that. Now, as for the distribution, the bad guys either handle it themselves, so they distribute directly where they would only be paying for the traffic, or they would distribute via partners, the typical pay-per-install schemes, partnerka affiliate programs, and the typical techniques for distributing malware were used: black hat SEO, infected blogs, drive-by downloads, and instances where the impact exploit pack was used were quite numerous as well. Okay, so here's again a user's perspective of the malware. This is a CarBurp control panel. As you can see, we didn't come up with the name ourselves. The bad guys named it. And to point out the interesting parts here, this prefix column, that's the affiliate ID. So the attacker will actually know who to pay in their pay-per-install scheme. As you can see here, there are a bunch of zeros in the live column, so this screenshot was taken after a takedown of the CNC server. And here there's the controls for controlling the individual bots. There's an option to execute commands and a remote shell, stuff like that. Here's the bank settings of the control panel. The interesting fact here is that some limits for the transactions can be made. So as banks aren't suspicious if a large amount of money is withdrawn in a single transaction. And over here you can see the different banks that CarBurp is targeting. And as you can see, these aren't only Russian banks. There's HSBC of UK. There are banks in the Netherlands, Israel, German Sparkasse, Latvian banks. So pretty global targeting of CarBurp. And so after those takedowns that I was mentioning, we've seen all the stolen data that was that the attackers laid their hands on, and that was a lot of stolen data. This is screenshots of over 7,000 cab archives with sensitive user information, and inside them, it contained all the information that the attackers were interested in. Screenshots, logins of banking credentials, key logs, and stuff like that for different payment systems. This is Cyberplat. This is iBank, an internet banking client used by different banks. Another one. This is a Ukrainian bank. Okay, so let's compare the different stealing tools. As I said, these are basically weapons in the hands of criminals for stealing the victim's money. And as I said before, CarBurp is the most technically advanced out of all of these, and is also its horizon, that the scope that it's targeting the countries, it's much wider. The functionality that it's using for remote access is different in all of these three. CarBurp is modularized, targeting specific banks, and over here, the information stealing has to be done manually. The complexity of the code when a reverse engineering obviously is the highest with CarBurp, and the similarity between all of these is that they all form botnets. Okay, obviously these aren't the only malware families designated for this purpose. Apart from all those that I've been mentioning, there's Shiz, which is one of the first sophisticated banking Trojans targeting banks in Russia. There's Spy, Ranbius, PlatCyber, which, as the name suggests, targets the Cyberplat payment system, and iWik, which is targeting the Kiwi payment system. Okay, and let's now move something a little bit different, yet very closely connected to all these. And that's hotprot. Statistics, again, pretty similar. Now, hotprot is a downloader. So it's a tool which cooperates with all these malware families that I was just mentioning. There were instances found where hotprot would be downloading RDP-DOL, Shelder, PlatCyber, CarBurp, and others. And it isn't a simple Trojan downloader either. It features some pretty interesting techniques, some anti-forensic methods, and basically techniques which are doing making our jobs more difficult. And it's been associated with real-world incidents where a lot of money was stolen. But let's take a closer look at the technical details of hot prod. So the installation, it starts becoming interesting from the very start. Unlike the simpler banking Trojans, which would, after installation, first directly contact the CNC, download what it needs to download, update itself, etc. Hot prod first penetrates the system, basically settles in before it starts doing all its dirty work. It consists of several modules. I'll describe each of them in greater detail. It has some techniques for bypassing AVs and intrusion prevention systems. It's using the add print processor trick during the installation. Now, for those of you that are following malware analysis, probably know that this isn't unique, and this was inspired by some malware before. So who knows which malware that was? Check if you're not asleep yet. That's TDL, the famous Olmaric or TDL rootkit, which is well known for using this trick. The driver, it uses an undocumented way, or an uncommon way of loading the driver by using the ZW set system information native API with the system at driver parameter, unlike the common way of installing drivers as registering them as a service. And the most interesting probably is that it stores its program code in the registry instead of files as on the disk. So clearly it's obvious that the hot prod creators are following the trends of modern malware of rootkits, because as you all know, rootkits in the past, what they would do is that they would try to hide the processes on the malicious processes on the system. They would hide the malicious files in the file system. Whereas modern rootkits, they would try to avoid this suspicious behavior, this hooking that could give it away, and try to bypass files altogether, such as TDL, stores its data in raw sectors, as raw bytes at the end of the hard drive. Okay, so let's take a look at the installation steps that are taken by hot prod. So first, a setup API DLL is dropped in the directory of the browsers on the system. The malware supports Internet Explorer, Opera, and Firefox. And following that, the add print processor technique is used to load the module. And if that fails due to some problems with admin rights, the malware escalates the privileges by using the MS-1015 vulnerability. If it succeeds, it will disable the Windows File Protection Service. And after that, it will replace the SFC files DLL and store the original file in the registry. I'll explain what the purpose of this is in just a second. Then it drops and loads the malicious driver using that uncommon technique that I just mentioned. Then it activates the whole payload after it's installed by opening up a default browser and navigating to google.com. Okay, so the code in the registry, the main binaries, the main code of the malware is stored in the registry like this. It's encrypted using some custom XOR and rotation and stuff like that. And these are the five registry keys that the malware is using. Core settings is used to store the main module, the main bot module of the Trojan. In this key, the original SFC files DLL is stored. This one is the binary, the kernel driver image. Over here is some loader code, which is used to load the main module. And then in the last one, hash seed, is where the malware stores its encrypted CNC URLs. So to get the whole picture, as you see, there are some different components in the malware. It might get a bit confusing. So this is the code. This is the code stored inside the registry. There's the loader code. There's the main bot module. There are the CNC URLs, and plus there are these two APIs: setup API DLL and SFC files DLL, and also the kernel driver. So what is all this for? What's the purpose? What's the infrastructure implemented by this malware? So setup API DLL. As I said, that's the DLL that's dropped into the installation directories of the browsers on the system. Interesting technique that it's using to inject this DLL into the browser's address space is called DLL hijacking. So when this browser process will be started, the Windows loader, what it would do is it would first check whether the DLL is located in the present current directory where the process image is starting, is located. And if it's not there, it will search the path environment variable and look for directories listed there. But the legitimate setup API DLL is in the system directory. So when the malware drops its DLL into these directories, the malicious DLL will be loaded instead of the legitimate one. And the purpose of the DLL is to get into the browser's address space and to inject the main bot module from the registry that I was just showing before. SFC files DLL, that has to do with Windows file protection that I was mentioning during the installation phase that's being disabled. And this gets onto the infected system by overriding the legitimate DLL, and the original is stored in the registry. And its purpose is, one, to be started once the operating system is started after reboot, and to load the driver if it's not running. And it also has the capability to update the software. Now, the advantage of that is that it's loaded by winlog-on-exe, which is a trusted system process. And the driver, SFC sys. Now, what that is doing, its purpose is the same as with setup API DLL, to load the main bot module into the browser. Now, as you can see, there is some duplicity in the functionality of these different modules, which shows how much work the authors of Hotprod had put into their creation. And basically, they're creating backup mechanisms in case one of them fails, and making the malware much more difficult to remove from the infected system. So what the driver is doing is that it registers the load image notify routine callback function, which gets triggered by the Windows loader whenever a module is loaded, and then it checks whether one of the loaded modules is one of these, within a DLL and so on, used by browsers, and if it is, then the browser injection takes place. Now, okay, so there are quite a lot of modules. So let's see how this is interconnected. As I said, the heart of the Trojan, the main components are stored not as files, but in the registry that's over here. And the SFC files DLL, which is residing in the winlog-on address space, loaded by winlog-on during the startup of the system, is able to update this payload and also make sure that the driver, the kernel driver, is loaded. And the purpose of the driver then is to make sure that the payload, the main bot module, will be injected into the browser address space. And the same functionality is implemented by that setup API DLL, which was dropped into the browser directory. So this duplicity backup mechanisms implemented by the malware. And while I've described this architecture all around the malware, the installation, and the self-protection techniques that it's using, the main thing, obviously, that it's using, since it's a bot, is the main module. And here the techniques are pretty obvious. It contacts the remote server, requests some additional malware to download and execute. And just to highlight quite an interesting technique that this module is using, is that the requests that it's using, that it's building up to contact the CNCs, they're building up with some junk values. So there would be the target URL, either from the URL list encrypted in the registry, or it has alternatives embedded inside the binary. And then there will be some parameters and values standard delimited. And the number of these parameters is not fixed, actually. It's a random amount from 5 to 9. And one thing that it sends in each case is the bot ID. So the attacker is able to identify the infection. But then additional junk is added to this HTTP request, such as the parameter can be one of these strings and others as well, and the value is one of these. These have no specific purpose. And why is the malware using these? Well, that's to avoid recognizable patterns in the network communication. So this is what it looks like in an illustrated form. The client will send a request to the CNC server, which will reply with the executable with the other malware, such as Carburp or Shelder or RDP-Door, for example. It's compressed with APLib, and that will be executed on the infected machine. And then a status information will be sent whether the installation was successful or not. Okay, quite a lot of statistics included in my presentation. Here's another one which shows the relative ratio. I just wanted to show how much of each of these families that I've just described is out there. So as you can see over here in the top, the barely visible red and blue colors belong to Shelder and RDP-Door. Now, that is not to say that these families are insignificant. These detections are still in the numbers of thousands, and people are having to part with their money thanks to these Trojans. But that is to show how much of Hotprot and Carburp is actually out there. So Hotprot, as it's the downloader, downloading and infecting other computers and delivering other malware, other banking Trojans onto the system, has the greatest share out of all these 4 families. And I already mentioned the similarity in the installation with TDL. And if you think about it, the functionality reminds me of TDL as well, since TDL would infect the system, use pretty advanced rootkit techniques, and then allow other third-party malware to be loaded on the infected system. So I think the question of why we need to pay attention to all this malware, all these families, has been answered during the presentation. I mean, these are tools which the attackers, the criminals, are using to steal money from the victim, to steal a lot of money. And just to give you an example of how much they're stealing, these are some numbers from the investigations carried out by Group IB. These are separate groups, which this one was stealing over $24 million over a period of time. These bad guys were stealing over $26 million. And according to the Group IB report, the global cybercrime turnover for 2010 was $7 billion. That's quite an astonishing number. And the share of Russian-speaking countries out of this horrific figure is over 1/3. Now, these numbers are for 2010. This report was published this year, and it's already known that in the second half of 2010, there has been a noticeable increase in cybercrime related to banking Trojans. So we're expecting the numbers for 2011 to be even higher, and the report will be out in the first quarter of next year. So to finish off my presentation, as I said, these banking Trojans are used as weapons, and they're targeting victims globally, but the share of Russian-speaking countries is quite remarkable, and these countries are both the origin of these Trojans as well as the targets of the criminals. And to say that the solutions would be cooperation is probably a cliche, but it's not only necessary to communicate between peers in the industry. Different Navy companies do this communication all the time, but also different sectors of the security industry, such as AV companies, law enforcement, banks, etc., etc. So while a good antivirus can be thought of as a bulletproof vest, the real solution will be to stop the person shooting. And hopefully, if we do it well, we'll be seeing more headlines like this. These people were arrested by the Russian police, and this group was actually using the shell door banking Trojan. And among other instances of theft, these guys also stole over $600,000 in a single transaction. That's probably not a very good idea. And also this headline, this guy is pretty famous, Pavel Wróblewski, a major player in the Russian cybercrime business, where mainly focusing on rogue AVs, where his company Chronopay is the largest processor of the payment of the online payments, and basically enabling the criminals to cash out from this dirty business. He was arrested this summer. So a big thank you to my colleagues who have a great share of work on this presentation, Alexander Matrosov and Eugene Rodionov from ESET and Dmitry Volkov from Group IB. And thanks to you all for attention.